ready for takeoff.
Hello, everyone. Hope you had a nice lunch. And thank you for coming to my talk. Today, I'm excited. I'm Varun. I work as a software engineer at Sourcegraph. And today, I'm excited to tell you all more about one of the projects that I've been working on recently, which is scip-ruby. It's a precise indexer for Ruby source code. And I'm going to slowly break that down for you on like what exactly that means. And I'm come all the way from Taipei, so I'm kind of glad to meet so many wonderful people here. Yeah. So let's get started. So just to provide a bit of background here, at Sourcegraph, our core product is a SaaS developer tool which helps you understand and change code at scale. So part of that includes searching code, navigating code, making large-scale changes, setting up dashboards for migrations, alerts for code changes, all the kinds of fun things. So today I'm going to be focusing only on one subpart of this, which is how we get the language-specific information into Sourcegraph, which is increasingly becoming a foundational thing for everything else. Because when you want to make code changes or you want to search code, you want it to be aware of the language semantics. So before I say 1,000 more words, first let me just show you a couple of pictures on like what we're trying to achieve with scip-ruby. So here's a Sourcegraph screenshot involving one of Shopify's open source repositories as an example. This repository has been indexed by scip-ruby before I took this screenshot. So I've hovered over the cursor or sub and clicked on Find References, similar to an editor, right? And below you'll see that there's a reference panel with different results. And there's two kinds of results, search-based and precise. So search-based can sometimes return false positives. As you're seeing, the first search-based result is for the string replacement method sub, right, which is not exactly what we were looking for. We were looking for the property sub. And the precise result does return the correct thing, right? So we need to do something more clever than string searching, right? We need to be aware of the language semantics, classes, methods, properties, things like that, right? So we want something like this, the precise thing to work, and that's powered by scip-ruby. Just one more example. So in this case, I'm looking at a code for a gem called Zeitwerk, and I'm trying to find references to the module defined in that gem, right? And if you look at the search results on the left side of the reference panel, there are many different repositories which return these results, and this includes GitHub repositories, so which means like you can search across gems, across GitHub repositories, GitLab perfors, different sources, right? And again, like here the name is unique enough that maybe a string search would be fine, but normally like what you want is to capture the semantics of dependencies between gems. So that you can understand, like, okay, what's connected to what, right? Or if there's a vulnerability, then how is it affecting your code? So basically, it's like we're kind of building IDE level navigation, right, in Sourcegraph. So this brings us back to the title of the talk, which I'm going to try to break down bit by bit. So you can think of the indexer part as the bit which is like the spinner in your IDE, right? Where it's aggregating all this information across source files and presenting it to you in a way where you can query it in many different ways, references, definitions, et cetera, right? And the thing is that navigation needs to be fast, right? Like if it's slow enough, then you're not going to use it. So at a very high level, right, like this is kind of where indexing fits into the pipeline, right? An indexer will take in all the source files, configuration, and emit like a single file, which is in the skip data format. That's an open source protobuf schema. And the index gets uploaded into a database, usually in a CI pipeline where it's like running on each and every commit, or it can also run as a repeating job inside Sourcegraph itself, so you don't need to set up your CI. After that, like when a client, like for example, you're trying to navigate in the web browser, right, and you're trying to perform actions like find references, go to definition, they will directly query the database, right? They won't talk to the index, or there's no running language server process like Solargraph, for example. There's nothing running in the background like that. Because what we've done here is we've separated out the analysis phase from the query phase, right? And we were able to do this because the code in Sourcegraph, it's read-only. You're not editing as you go, right? So because the code is read-only, we just do the analysis once, right? And now the query can be optimized like a typical database query, right? The other benefit of this is that the database, the backend, the client, all those things, they're kind of mostly language agnostic. Whereas if you were to use a language server, then the query part also needs to be language aware. And so the language aware part is actually restricted only to the analysis, which is happening during indexing. So that's kind of like roughly where indexing is placed, right? So that's the indexer part, right? You can think of it as like an ahead of time language server instead of like running just in time while you're navigating the code. And the other thing is like it prevents us, like it doesn't need us to run a language server for every client, right? Because you may be browsing different kinds of code, and there may be millions of lines of code. So what's up with the Sorbet bit? So if you're unfamiliar with Sorbet, it's a type checker for Ruby by Stripe, which adds support for gradual typing with optional type signatures. This is similar to TypeScript if you've written TypeScript, except Sorbet is very fast compared to basically every other production type checker that I know of. So scip-ruby is based on an open source fork of Sorbet. And this bit is important because I'm going to be referencing a bunch of Sorbet internals later in this talk. So that's why Sorbet internals come in. And I know in the opening keynote, Matt's mentioned that performance doesn't matter that much for some cases. But in this case, for us, like Sorbet's performance is an important feature because customers can have very large code bases, right? And ideally, we would index each and every commit, so you can just navigate without like having to think, oh, am I on the main branch? Am I on a different branch? Something like that. So the other reason for building on top of Sorbet is that Sorbet already understands the semantics of Ruby code at a deep level. So the index can be precise like an editor, right? Sorbet also has an LSP. And so that's the precise part in the subtitle. We do not want to look at just the syntax or like rely on some kind of heuristics or like machine learning or what have you. And like that, we do not want to compromise the quality of the end result, right? Like it needs to be as good as it can be. And so that's another reason to build on top of Sorbet. So the cross repo bit is something that I already kind of showed you earlier, right? We want to be able to navigate between gems, GitHub repos, GitLab repos, Perforce, et cetera, right? We do not want to be limited to within a single repository or like even within a single code host because customers are using different kinds of code hosts. Last bit is for every Ruby developer. So sourcegraph.com, it's free to use for open source maintainers. You can upload indexes for your open source repositories that you own. And anyone can navigate that code. Otherwise, you can also get a license for a single tenant managed instance or self-hosted instance. Well, so that's like just the opening slide. So let's get into the details now. So earlier I showed you this abstract picture of indexing. Source files go in, index comes out, right? The only tricky part here is we need to figure out what goes in the middle, right? So since we've decided to build on top of Sorbet, we first need to figure out like where exactly will the indexer fit inside Sorbet, right? Like because Sorbet is kind of not a small code base, so we need to figure that out first. So this is a simplified version of Sorbet's internal pipeline. We start with the source code in the top left, right? And we end up with this control flow graph at the bottom right. There's a bunch of things in between, right? Like there's some tree representations. If you've attended the talks by the RubyConf talk by Carl D'Oliveira on the first day, or the language server talk by Vinny's talk on the first day, right? You must have seen like what the parse tree or the abstract syntax tree look like. In our case, those aren't super important because the main thing we care about, right? Like we want to have access to type information so that we can show it in like, for example, hover documentation, right? And you'll notice the type checking and inference that's happening on the control flow graph, right, at the bottom right. So we want to be operating at that layer after type checking has finished running. So that's where we'll emit the index after we have access to type information. So that sounds reasonable, right, so far. So the next question is like, OK, what does this control flow graph look like, right, if you're going to get the index out of it somehow? So here's like a very small Ruby code snippet, or like somewhat artificial, right? I've got a fragment of a fizzbuzz function, and you perform a modulus operation called plus equals if that operation succeeds. And so I've just like, so that this fits on a slide. And so now let's see what the control flow graph for this like code snippet looks like. So OK, there's a fair bit of things going on. So let's walk through it bit by bit, right? So first, let's just try to identify some patterns in the structure. First thing you'll notice is that this flat bit of code has like actually been broken up into graph structure, right? Like there's a control flow graph, right? And there's these different blocks which are called basic blocks in compiler jargon. And you've got these explicit arrows depicting control flow. So for example, the first block has an if at the very end, right? And it's got these two edges depicting like what happens if the if is true or if it's false, right? And so basic blocks are kind of like small functions like within a function, right? Except that control flow is like not a part of the basic block. It's external to the basic block. It's a part of the edges, right? The other thing to note is that like within each line inside a basic block, which in Sorbet it's called an instruction, right? They kind of look like Ruby code if you squint a bit, right? Okay, there are lots of dollar signs. Like there's a bunch of things which are like marked with like temp, right? Those temporary variables, not super clear where they came from. And like it's more verbose, but like if you understand Ruby, you can understand the control flow graph structure too, right? And so the index, it needs to describe the source code, right? Like it doesn't, like the control flow graph is an implementation detail, but we're working with the control flow graph. So we need to understand the correspondence between the source code and the control flow graph if we're to emit the index correctly. So first, let's look at the expression inside the if, right, which is this I mod 3 equals 0, right? So as you can see, it's getting translated into 4 different instructions. Each literal assignment, like it's literal is becoming like a temporary variable, right? And the percentage and the equals, those have become method calls, right? If you've done implemented like operator overloading, you've seen that percentage and equals are, even though they look kind of different from method syntax, they're actually just methods, right? And so that's made very explicit in the control flow graph structure. The other thing is that the overall logic has to be the same, right? If you want to sound fancy, you can say that the translation is semantics preserving, but the basic idea is like, okay, yeah, it needs to mean the same thing, right? The result of the modulus operation, right, which is temp1 in the second instruction, is used as a receiver for equals. The receiver is like just before the dot sign, right? And so what's happening in the source code too, like the same thing needs to happen in the control flow graph, even if like with a bit of indirection, right? And so one nice benefit of using these temporary values is that now every method receiver, as well as the thing before the dot, right, as well as every method argument, now it's a variable, right? It's either like a named variable, like $I, right? Or it's like a temporary, which we just made up on the fly. But we don't, when we're trying to traverse these things later on, right, like we do not need to traverse like a tree structure, we don't need recursion, we don't need a visitor pattern, right? Everything becomes simplified when we're handling it. So this flattening is kind of very, very useful for further processing. So the other thing, as I mentioned, right, like control flow is made explicit in the edges between different basic blocks. So the if has two edges pointing externally to BB1 and basic block 2, right? And the other thing that's kind of interesting here is that regardless of whether the if statement gets executed or not, right, what's happening in the rest of the function still needs to happen, right? Which is why there's a further like fall through edge from basic block 1 to basic block 2, because basic block 2 is still going to get executed in the original function regardless of whether basic block 1 executed or not, right? And so this also means that there's no edges like that go into the middle of a basic block, right? That's the idea around like, yeah, we'll make control flow explicit in edges, right? Like there's no control flow within a node. So the other thing is like, okay, the body of the if statement, right? There is a out plus equals fizz. And so that's also like kind of done similarly, right? Like the literal becomes assigned to a temporary, you call the plus equals method, even though here out in the source code, out is like an L value, right? It's on the left-hand side of the plus equals. But from a practical perspective, it's essentially calling the plus equals operator on out, right? And so that's what you see is the second instruction, right? So again, like the theme, there's a constant theme, right, of like simplifying everything that's in the source code to a handful of instructions. And you'll kind of see this repeatedly in the control flow graph, where the control flow graph actually just has 17 different kinds of instructions, whereas if you look at like a parse tree or something, it's like 90 nodes or something like that, right? And like Ruby syntax is very flexible. The control flow graph is kind of very simple. So okay, so that's like what the control flow graph looks like, right? So how do we emit an index for the structure, right? So we can break that question up into two subparts, right? Like how do we handle each node in the graph, right? And how do we handle each edge in the graph, right? So for the edges, the first main thing we need to do is traverse the graph in like topological order. By that, what I mean is like here, like I've drawn the graph with the arrows like constantly pointing downwards, right? And so that's kind of essentially breaking up the graph into different layers, right? And so topological order, all it means is like, okay, you're going like traversing the blocks from top to bottom, right? You don't, for example, you wouldn't traverse basic block 2 before basic block 1, right? That's all there is, right? And the reason you do it is because definitions, they need to come before usages. So okay, so that's the edges, right? And now let's look at the nodes. So let's just look at the first basic block for simplification. So here I've got like two parameters, $I and $out. And so what's going to happen is like we're going to record that these are parameters to the function, right? So we'll either maintain like a couple of arrays for definitions and references, or like they could be hashes. We also need to record like source locations, so we know like what's the original source location this corresponds to. So when you hover over something, we know, oh, it was I, the parameter, or like the out parameter, right? And so, okay, so I and out, they're both named variables, right? Like they're not temporaries, right? And so that's why we need to record them. And then essentially it's a process of like, okay, iterate over each instruction, right? And like you look at what kind of instruction it is. Are there any named variables, or is it just temporaries? And so temp 0 equals 3, right? There's no named variables, right? Like there's just a temporary which is like entirely made up, right? And so we don't need to emit anything for that. Nothing to emit for 3, it's just a constant value. Now we look at the next one. Here, the receiver, $I, right? Like that's a named variable, right? That's a reference to the original I in the parameter list, right? And the percentage, right? That's an operator, right? So that's again a named method, and like we need to emit a reference for that. So when you do find references on percentage, you can find this call. So we'll add two references here to the references array, marking the parameter and the method. And essentially, we just repeat this process where we're like, okay, is this a method call? Look at the receiver, look at the arguments, look at the method itself. Look at the left-hand side. In this case, all the left-hand sides are temporary, so it doesn't matter. And then again, like when we get to the fourth instruction, we'll see, oh, there's an equals equals, so we need to emit an extra reference for that, right? So in essence, right, like even though Ruby code might seem kind of complicated, or like there's just like so many different kinds of syntax, right? We've kind of reduced the problem of like, how do we power this navigation tool to essentially 5 loops and like one extra function, which is like, okay, which will look at like, oh, what is this a named variable? Is this a temporary, right? And then it will optionally emit a definition or a reference, right? So I think like one takeaway I want for people here, like is especially like if you're a junior, or like you had a compilers course in university and thought it was pretty complicated, right? Is that actually a lot of compiler stuff kind of boils down to like finding the right abstraction, right? In this case, the core indexer that I wrote like over the past 3 or 4 months has been like about 2,000 lines of code, 1,500 lines of test inputs, right? And conceptually, the implementation is essentially a pure function, which is saving things into like a hash table or something, right? There's not a lot more going on, right? Like once you understand the core abstractions. So that's mostly all what the indexer does, right? Like because we've essentially traversed each and every piece of Ruby code snippet, right? Like that there was to traverse, right? Except not quite. We need some hacks to actually get it to work as well as it should, right? And so I'm going to describe one of them here. So remember the Sorbet pipeline from before, right? Like it had all these different representations, right? And there's like type checking going on, right? So we decided to work with the control flow graph because that's where the type checking and inference was happening, right? However, in practice, Sorbet sometimes it will not even do type checking, right, for certain files. So Sorbet has a concept of strictness levels. So if you don't add a magic comment at the top of the file which says type true, then it will not even try to type check the file, right? But the problem is, like, some of our customers, they're not using Sorbet at all. Some of them, they're only partially adopted Sorbet, right? But we want code navigation to work for everyone, right? That's every Ruby developer thing. It's not like, oh, it should only work if you're using Sorbet. So how do you kind of square that circle, right? Because like we want access to this control flow graph, right? The other option is like, oh, do we need a separate indexer for the parse tree or the abstract syntax tree, or do we need like a whole new indexer which is not based on Sorbet, right? And so so far, like our thinking has been that's maybe perhaps a too complicated thing to do, right? Instead, let's add this hack, which is like literally ended up being like a single line in the code base, which what this basically says is like, okay, if we're running in scip-ruby mode, then typed false, which is like Sorbet's way of saying like, okay, I'm not going to type check this file. What we do is like, even in that case, we force Sorbet to type check the file and generate the control flow graph and everything, and just keep proceeding, right? And what this means is like we do end up with a control flow graph. Like it may not be necessarily perfect, but it ends up working surprisingly well, where Sorbet can handle like lots of errors in code anyways. And code navigation does seem to work like based on my testing. Like, of course, you're welcome to try it out and break it and report back. I'll share instructions at the end on how you can do that. But like this is kind of surprising to me as well, like on how robust Sorbet is with code which is actually doesn't type check, right? Like, it can generate thousands of errors, but we can just suppress them, right? Because it's not terribly interesting. What's of interest is the navigation. And so, okay, so that's how the indexer works, right? Like, okay, vanilla Sorbet plus some hacks, right? Let me briefly describe how we test the indexer. So essentially, we rely on what you'll commonly call expect tests or snapshot tests or golden tests, right? We serialize the index into a human readable format and like annotate the source code with like comments like this, which like show the source ranges for different definitions and references, right? This way, it becomes very easy to identify if a patch like, oh, did it add the right definition that I was expecting it to, which was getting missed earlier? Did it actually start skipping some definitions, and like we need to fix that, right? Diffs become very easy, right? And so this is kind of one of the nice benefits of the layering that I showed you from before, right? We're only doing analysis, right? Like we're not concerned about what the browser is doing, right? We're not concerned about like, okay, should we be testing along with the browser? Because like browser tests can sometimes get flaky, right? Testing is now very simple, it's fast, and like you can understand diffs, right? So it's kind of very predictable as well. And so that's yeah, that's kind of most of what I had to say, right? So scip-ruby is open source and it's available on GitHub, right? If you're an open source maintainer, an existing Sourcegraph customer, or like interested in potentially in using Sourcegraph, then you can find instructions in the scip-ruby README, which describe how to try it out. I tried to make configuration as simple as possible. Like if you're using bundler or like some standard configuration, it should mostly just work like with a couple of minutes of setup, and you should be able to upload an index to sourcegraph.com for open source code, and just like start navigating your code. There's a couple of example repos as well on sourcegraph.com, which is this Shopify one and Homebrew. So the Shopify one, as an example, is like it's 100% Sorbet. In some ways, it's like kind of best case, like what you can get. Right? I'm sure there's still bugs there, but that's kind of like one example. The other is Homebrew/Brew. So I'm sure many of you know and love Homebrew. And so the Homebrew code base is kind of, I think it's like maybe 40% Sorbet or like 30% adoption of Sorbet. But you'll be able to navigate code even within files which aren't supposed to be type checked by Sorbet because of that hack I mentioned before. And so that's another example of like what kind of navigation you can get even when you've only partially adopted Sorbet, right? And to provide feedback, there's a couple of different ways to do it. The QR code there is for our Discord, the Sourcegraph Discord, and there's a scip-ruby channel. You can also find the Discord link on our community website. And the other way you can provide feedback to me is via GitHub issues, so those are totally fine too. Also, like if you just have a question, right, like you don't even like have an issue per se, like it's totally fine to open up a GitHub issue. And yeah, thank you. If you have questions for me right now, I think we have a bit of time for questions. Or yeah, I can take them afterwards as well. Thank you.